One of the first major milestones in constructing a house is putting down the footings or foundations. They're not called foundations for nothing, they're the basis of a stable building structure. And if you don't get it right, you could end up with settlement, cracking walls and water penetration. The three factors that determine what kind of footing you require is topography, soil conditions and structural requirements. So whether you're building on a flat or sloping site, if you have soil with high clay or sandy content, or you need to add piers to deal with filled land are all things you need to consider, not to mention the size and style of your house. For a two-storey family home like the CSR House, you're going to need a slab system which can accommodate the movement in the ground during prolonged changes in climate.
The main reason we're using a slab on ground on this side is because it's a fairly level slab. There's three types. There's a waffle slab or a stiffened raft we could use, and now the CUPOLEX system. If we were to go to a suspended slab, we'd have to do a lot of work to get up above the ground, and that's quite costly. We have to extra perimeter brickwork. Whereas you can see on these perimeter slabs, there's no extra brickwork other than the work which comes straight off the slab.
Concrete has a high volume of thermal mass, which is really useful in regulating the internal temperature of buildings by radiating or absorbing heat as needed. Mass is useful in most climates, and particularly in cool climates or climates where there's a high diurnal range of nighttime or daytime versus daytime temperatures. However, thermal mass only works when positioned appropriately. You shade it from the hot summer sun and you position it to attract the warmth of the lower range winter sun. So poorly positioned thermal mass can have disastrous results, whereas strategically positioning the thermal mass in the house can really aid the thermal comfort of the internal environment. So the CSR House has the slab in direct contact with the ground, which allows us to thermally couple the internal temperature of the house with the ground temperature. The ground temperature is more stable, which gives us a result that we use less energy to heat or cool the house, which is vital in delivering a sustainable home. The concrete slab that we've used in the CSR House is a variation on the traditional waffle pod slab. Traditional waffle pod slabs use polystyrene void formers. We're using a system called the CUPOLEX dome system. CUPOLEX domes are made from recycled plastic, and they're forming the domes or the voids underneath the concrete slab by basically forming volumes and pockets of air rather than being a full solid polystyrene block. Polystyrene is quite nasty on the environment, and recycled plastic PET that goes into the CUPOLEX domes is obviously a recycled product, so we have much less impact on the environment.
We can have a lot of flexibility in how we interlink the domes, whereas the waffle pod systems are purely void formers, and in accordance with the relevant codes, they should only be placed in single units with a concrete beam in between them. With these systems, we can do quite large areas, all interlinked with domes, which we call dome clusters, and we find that's a benefit in costs and speed of construction and ease of construction as well. The arching effect on the edges of the domes, and also inside the middle of the dome there's the cone shape, which gives them a lot of strength as well. The benefit of that is that every corner of the CUPOLEX dome bears onto the ground and gives it inherent strength, and it's like a composite plastic concrete structure which you can't get in other forms of construction for slabs.
So with the CUPOLEX dome system, basically the entire CUPOLEX pods were delivered onto pallets, whereas most traditional waffle pods using polystyrene, they need 1.5 trailer loads effectively of polystyrene. So you have less transport requirements, less waste on site, and less mess when you're forming when you're doing the preliminary works for the concrete.